Welcome to Beyond the Forecast. That's George Konkov right there. I'm Jeff Edmondson. We are going to be talking all about astrophotography and imaging the cosmos.
Right.
Are you ready?
I am.
This is the expert. So George you've been taking images of the stars and of the sky through a telescope for how long?
Wow. I got my first telescope, can you believe, in 2012. So it's been like 13 years.
Okay.
But I wasn't always into astrophotography. It's all started with the visual observations. Then I was kind of trying just a little astrophotography, going back and forth. And I kind of found myself really enjoying doing astrophotography since 2020, I believe, 2020. Well, but pretty much when the COVID was.
Yeah.
When the
COVID.
COVID hit, yeah. And since then, I've been really into deep sky imaging, planetary imaging, so forth, all the different stuff. Yeah, kind of like that.
So just a quick little snippet so everyone can see some of his work, and we're going to get into these images later on, but I just want to show people okay, what, are you just taking pictures of the moon? No, we're getting pictures and images that are like this. So absolutely phenomenal. So we're looking at the Elephant Trunk Nebula in this. We're going to talk about how we got this in a little bit, but we want to get into some of the basics. And one of the biggest questions and most frequent questions that I always get, George, is what telescope should I buy? So I would assume that most people are asking this question based on the fact that they want to do visual astronomy. If they want to get into astrophotography, we can touch on that too. But for a starting telescope, where should we begin on that?
The starting point, there are two things. First one is the best telescope is the one that you can afford. Second thing, the best telescope is the one that you already have. So the thing is that there are varieties of different telescopes ranging from $100 to $1,000, right? And the first thing when you're consider before buying is you got to determine your budget on the telescope, right? Because $200 telescope and a $500 telescope, they can show you totally different things, and they have different forms and shapes and telescope schemes like refractors, reflectors, mixed telescopes, so-called K-to-D telescopes and stuff. Yeah, so you want to go one by one to kind of, because the thing is, each telescope, it also has its own purpose. So for example, if you live in a city, then you probably won't be able to enjoy deep sky as if you would watch outside of the city. So maybe you want to concentrate on just planetary imaging. Imaging. Visual observations, right?
Visual observations.
And if you have a chance to go outside of the city, on the countryside or somewhere suburban area, maybe then you want to go with something that doesn't magnify a lot, doesn't have a lot of magnification, so you can enjoy deep sky objects. There's
a lot of different, there's two different types of base telescopes for how you set it up on the ground and how you look at the sky. There's alt-az, where you're just basically flat, or equatorial. So what are those? Describe that.
So there, we can look at the telescope as also what kind of mount does it stand on. So the mount is something that basically carries the telescope, and as you said, those we have alt-azimuth mount, that basically it goes left and right, up and down. And there are also equatorial mounts, where basically before using the equatorial mount, you need to do polar alignment. It's to align the mount of the telescope with the Earth's axis of rotation, so that basically whenever you point to somewhere, like for example at the moon, instead of going up and right, let's say, you just use one axis and you basically move the telescope towards one side. So the process is a bit harder for the beginner probably, but it's much easier to observe such things where you need a higher magnification, because the higher magnification you use, the faster object moves for you as you observe it, right? Or if you use a lower magnification, then the speed of the movement kind of decreases a bit, so it's easier to observe. And the other type of mounts is so-called Dobsonian mounts. So there was an American amateur astronomer, John Dobson, and the guy was into kind of advertising the space. So what he would do, I believe he would live in California, maybe in the LA area, I'm not sure, but what he would do is just go on a crossroad just in the middle of the city, getting his telescope and hey guys, come on in, let's look at the moon. You want to see Jupiter, you want to see rings of Saturn, right? And stuff like that. So the point is that the Dobsonian telescope, it's a reflector telescope, but instead of using a mount, it actually stands on a portable mount, and it goes in alt-azimuth mode, up and down, left and right. And the huge benefit of the telescope like that is that it's so much cheaper compared to the telescopes that have mounts like alt-azimuth mount or equatorial mounts. So it really depends on what you want to do. And the thing is, when talking about the telescope, as I already said, you want to start looking at the budget that you have first. Second, you want to really understand where you can use this telescope. So for example, if you live in a city and you have a balcony, then the Debsonian is not going to be an option for you because it's a bigger telescope.
Right.
The mount is lower, right? So maybe you want to go with something on the alt-azimuth mount or use shorter telescopes like Schmidt-Cassegrain telescopes. But if you have a chance to go outside of the city, let's say go in a field where there's nothing, then you can get a Debsonian telescope and basically use that.
Yeah, you can grab more light in the bucket of the telescope,
well.
essentially, which is really great. The one thing that I want to also bring up, too, is that if you're looking for a telescope, you need to be able to answer the question, what do you want to look at?
Yeah.
Are you looking at deep sky, like we mentioned, or are you looking at planetary? If you're looking at planetary, you can do that in the city because the light pollution won't block out the planets. If there's tall buildings or you can't have a good view of the horizon, well, you may not be able to view some planets. Specifically, Mercury is pretty much the one. Maybe
It's hard,
Venus,
yeah.
if that gets high enough. But those two, because they're inside of us on the solar system, so they don't get all the way outside covering the whole night sky.
Yeah.
Another thing that you have to remember too with planetary is that the planets aren't always out. So sometimes throughout the year there's no planets to look at, and then sometimes throughout the year there could be all the planets to look at the same time.
Yeah.
So it's a hobby that if it's planetary only, then it's some times of the year. If you want to do deep sky, then what? All throughout the year?
All throughout the year, pretty much.
Except
yeah.
that there's a full moon.
Of course.
Yeah, because the light pollution that brings too much light. So full moons, they're pretty, but they're not great for really astronomy
Yeah.
looking through the telescope.
Yes, that's good. That's right. And also the thing is with kind of observations is that the reason we can see the planets inside of the city as well as the same way as we would go to the countryside is that thanks to our sun pretty much. As planets, they reflect the sunlight, and that's why we can see them like and they're also located in the solar system. They're close to us, right? But if we look at deep sky objects, the reason they dim and the reason we cannot see them in the city lights is that because they far away, and some of them reflect light, but some of them do not reflect light. They emit light, and this light is relatively dim. As we're gonna take a look in one of my images, like the object, it's impossible to see it. Basically, if you take a really big telescope, you won't be able to see it, the nebula. But if you use a photography, then you'll be able to see it. And same pretty much works for looking at some different deep sky objects. Some of them, whatever is closer and brighter, you can kind of see it in the city. But if you go like an hour of driving, it will be so much better, and the difference will be crucial.
So this image here, what are we looking at here? This is one that you took.
This is a composite image. On the background, there is a star cluster called Pleiades, and on the foreground, that's our moon. And this image, as I said, it's a composite image, and I didn't take it during like one night. So basically what I was doing is, I don't remember for sure, but I think it was during the winter season. What we were observing is that the moon was kind of passing in front of this Pleiades star cluster. And as you can see, the face of the moon is almost full, so it was really bright. And what I was doing is taking the pictures of the moon actually passing in front of the star cluster. And on like my raw images, I could see the moon details and only the brightest stars of this Pleiades star cluster. So I was taking pictures of the moon separately, and talking about the star cluster itself, I would take images of it like a month before. So when there was...
So that was this.
That was this image.
That was this. So we take the moon out back.
Yes. So
forward,
basically,
yeah.
I just
Didn't go
combined...
that far.
So yeah, basically I just combined these two images, but the cool thing about this image is that sometimes people ask, like, when occasionally I talk to people and they're like, oh, you do astrophotography, you do astronomy.
Right.
You gotta have a good telescope that does like 1,000, 1,500 magnification, right?
Right.
And that's one of the most common confusions that some people have, just because simply they don't understand it. But the thing is, like what you can see on this image, is that a lot of objects, deep sky objects, they're actually huge in the sky. And just because we have light pollution, we don't see them as well, like in a good quality, right? But the image that you showed with the moon, that's like the same angular size. The angular size we call the angular size, it's the measurement of how the object appears in the night sky. And yeah, the Pleiades, as you can see, it's like what, 2-3 times of the size of the moon.
Exactly. So that's the key thing here, because if someone's shopping at a store and they see 10,000 magnification, you think the more the better.
Yeah.
But this is the simple way to look at it. So if you're looking with a really powerful telescope, one star in this constellation, in this cluster of stars, essentially we could call it a planet. Let's just pretend that one of the stars is a planet. That's how big a planet would be.
Yeah.
So in this view, okay, we're looking at a spot of light. The planet would be very small. That's not the magnification we want. We want to be able to have a smaller angular size to really dive down at looking at that. But when we want to look at a constellation, a nebula, then we don't want that super zoomed in view. We want a nice wide view, because if you had one planet in here, that'd be just one dot out of this whole image.
One of the stars could be the size of the one that, like, if you place a planet, there will be the size of one of the stars that you can see, and not even the brightest star.
Exactly. So this image here, which one is this? This is M16?
This is M16, yeah, also called the Eagle Nebula.
Okay.
And that's one of my recent images. And in order to take this one, I had to spend 27 hours of constant imaging. So it's not something that you take over one course of the night. This one I started taking in April and finished late June, because all these rains that we got, the Canadian smoke, and then the heat wave that we got, everything affects astronomy, astrophotography. And yeah, it took me like almost 3 months to complete the image, although it's only 27 hours of integration time. Now, the thing is about this picture as well is that I was taking it using special narrowband filters, and that basically represents so-called SHO style image. S stands for sulfur, H stands for hydrogen, and O stands for oxygen. And like whatever reddish colors you see on the image, those are like a sulfur regions of the nebula. Whatever greenish is hydrogen, and bluish is oxygen. And that's kind of the same as the Hubble Space Telescope images, and it's called Hubble style palette of the image. So we as like amateur astrophotograpers can kind of do the same, not at the same resolution, of course, but at least the same color shapes. And I don't know if you can zoom the image in a bit.
Yes, that's what I was actually going to do. So let me see if let's take that full. So like this is not just a small resolution photo image or picture file.
Just the image has a really nice field of view. But in the meanwhile, it also has nice resolution. And the structure that you see in the middle of the frame, it's called Pillars of Creation. And
that's right here.
Yep. And this structure actually they made back in it was 1990, either 1996, 1998, when the Hubble took the image first time of the structure and became really famous. Like the image of this area became really famous back in the time. So yeah, it's kind of the same area.
A lot of people have seen that image from the Hubble.
Yeah.
But you have to realize we're seeing this. If you have a telescope and you have everything set up correctly, you can capture this from your backyard.
Yeah.
If conditions are right, which is incredible. Look at this. So again, all the dots are stars or maybe other distant objects. So one of them essentially is a planet. So that's, again, we want to have a nice wide field to capture all of that light in this whole area to be able to get the image that we have here, because otherwise you would be getting it piece by piece and you'd have to do a mosaic to splice it and stitch it all together, and that would be unnecessary.
Right.
How many hours does this take to capture?
So this one was 27 hours of exposure time, and as I said, I was using 3 different filters, so pretty much 9 hours per each filter. So let's say I got like one night, I collected 3 hours, next night it was cloudy, a night after it was clear again, so I got another 2.5, 3 hours of data, and slowly, night by night, hour by hour pretty much, you collect the light, and that's how you get images. Like the more light you gather, the more better image you can get.
So this is just Stellarium. If you haven't used this website before, this is a great one for all of you that just to check out. So we locked in on where the Eagle Nebula is. We just set the time to right now. And just roughly, as we go throughout into the night tonight, you can see how this zone is generally in the southeastern sky, where the moon would be positioned more to the right over there. So it's not a night for planets. Mars is out there, but Mars is low in the western sky. So this M16, the Eagle Nebula object, this cluster, is in this position, southeastern sky. Just kind of give everyone a little perspective
what we're
on where it
talking
is. That's a phenomenal image, though. This is a phone wallpaper type image. This is good stuff.
Thanks.
So I want to kind of switch courses here, and then we'll go back into some of your other images, George. The smart telescopes, the automatic star finding telescope. So we could really put that into two different buckets because, again, we're shopping for a new telescope. You could look for a Dobsonian. You could look for an SCT telescope. We kind of got that covered, but we haven't talked about the newer types of telescopes that you set on the ground and they connect to your phone and you say, go.
That's it.
And that's all you have to do. You don't have to do anything else. So you don't have a lot of experience with those. Last I heard, you kind of went like, that's not a real telescope. Tell me about that.
It wasn't like, so it's, don't put me under the bus.
Yeah, no, I'm not, no.
No, the thing is, so yeah, we have kind of, nowadays there are three main spheres where you can do astronomy/astrophotography. So you can do, as we already covered, visual observations, you can do astrophotography, and you can use smart telescopes, which is astrophotography, but not astrophotography. So the thing is that, yeah, smart telescope is a portable thing that has smaller sensors, smaller telescope itself. It's usually, they have them like 30 millimeters aperture, 50 millimeters aperture, right? And they don't have that much magnification power, but what they're good at is at imaging deep sky objects. And what they're good at as well is they're pretty much really good for people that just got an idea. Like, you know, they were browsing any social media, they found this random picture of the space, and then by any chance they have this ad of the smart telescope, and they're like, hey, I can get a smart telescope, and the price nowadays ranges from somewhere like $500 to $700 on average,
Yes.
right? And we can call them models, right? On the most popular.
Yeah.
So the most popular will be like either ZWO or the Dwarf Lab telescopes, right? They're most affordable and the most common in the industry. So yeah, basically what you do, instead of like what you would do with the equatorial telescope, you gotta do polar alignment first. You gotta know what the object is. If you have a go-to function, of course, you can do it automatically. With the smart telescope, you literally download the app on the phone. You place it anywhere. I mean, of course, you want to have the clear view of the night sky, but
Right.
it doesn't matter if you point it towards the Polaris, whether you point it towards the Milky Way, right? You download the app, you launch it, then it takes random image of the night sky. Then it's plate solve the image. Plate solve is basically where it and tries to understand where it looks at based on the position of stars and everything. And once it understands where it looks at, it synchronizes with the position of in the night sky. And then what you need to do is just, hey, I want to look at M16. You punch in M16, hit go, telescope sleuths to the M16 and takes images of it. So it's really good for people that don't know what to do, but they want to do something.
Right. I think they're great if you want to get an image of a distant nebula or a distant object. They're great because it's so easy, and the amount of time that you need to set it up is so much lower. And that can be a hindrance because the smart telescopes are super light. They're essentially the weight of, not a smartphone, but they're not
They're like
heavy.
the size of the book.
The book.
Like the book that I have here, one of the telescopes, like a Dwarf Lab, I believe, it's going to be exactly the same size.
Yeah.
So you can easily
Versus
take
hundreds,
it.
like 100 pounds.
Yeah, those telescopes really good if, let's say, like we live in Hampton Roads, and you got a cruise not a cruise, you want to travel to New Zealand, to Australia, right?
Yep.
Where the southern hemisphere is. You can take this telescope, put it in your backpack, travel to the southern hemisphere and take images out of it. And that would be really hard to do if, let's say, the telescope that I used to take M16 image, it wouldn't be that easy to take on the airplane and travel with you to Australia.
Right.
But smart telescope, it's something more portable and pretty much easier to use. Of course, the results are going to be they're not going to be exactly the same as with the more professional stuff. But for beginners, for people that want to try it out, why not?
I feel like I'm regretting my time when I went to New Zealand back in February because I didn't take a smart telescope with me. I don't have one. But I went to the night sky was absolutely dark and beautiful. Maybe, I don't know, Bortle 1. It was very dark.
That's
so
good.
that's, I don't have the website up right now, but it just shows you where the light pollution is. So New York City would be a 9. Essentially on the scale. You can't see anything but the moon and a couple of planets. Compared to Hampton Roads, I don't know, a 7, 6?
Depends on where you are. Like
It does.
Portsmouth, we 7 or 8.
Yep.
Norfolk will be 8 or 9.
Yep.
Where I live, Williamsburg, where I live, it's 6, but my telescope's located at the family's house, which is portal like 4.55,
Yep.
which is better. That's why pretty much I can get images like that just because of the location where I am.
Yeah, you have the location. So finding a dark sky is really, really difficult in areas where there's population, because if you want to have a really dark sky, you have to be willing to drive.
Yeah.
And hopefully you'll have the clear skies too. You should have figured that out before you hit the road. But I mean, it's at minimum an hour drive out of a city, but it can be even longer than that. It's best to travel into other spots in the country where the darker skies will be easier to get to, because if you're trying to find dark sky on the East Coast, it's tough. It's really hard, but there are some spots, and you can look at the light pollution maps, and you can find some ways. So we're going to take a quick break, but what we're going to do after we come back is we're going to take a look at this image. So stay tuned. We'll be right back after this. Welcome back to Beyond the Forecast. We have more to talk about, and I want to talk about solar imaging, because you can use your telescope to look at the sun with proper filters.
Yep.
Not with just eclipse glasses. You need to have a filter that goes on the cap of the telescope. The smart telescopes that we just talked about some of them can also be used for solar imaging as well. You can look at a lot of different things based on the filters that you have for looking at the sun. A simple solar filter will look at for sunspots, correct?
Yes.
What else can we see when we look at the sun?
So with the sun, that really all depends on what equipment you use. So if you use just a basic, they call them white light filter, yes, you primarily focus of the solar, it's a solar surface, it's so-called photosphere of the sun, where you can see the solar spots, the darker structures of the sun with a lower temperature compared to the surface. If you have a bigger aperture telescope, then you can see solar granules, like basically these really nice spots. So it's not going to be, the sun is not going to appear as a white disk. It's going to appear as a disk with some details, especially around the sunspots. If you use a special solar telescope, and by solar we mean the one that's actually dedicated to solar imaging. So for example, if you point this telescope at night, you're going to see nothing.
Right.
Just because it has special hydrogen filter. And like if we take a look at the light wave, right, as like, for example, I'm looking at you, I see all these blue colors, I see green colors, red and everything.
Yeah.
What the solar telescope does, it takes a tiny sliver of light and focuses only on the sliver of light. And if you look at the sun, which is really bright, then you can see its solar prominences, solar corona in some cases, or
So we're essentially
coronal
taking
mass ejections. So you're really concentrating on the small, tiny sliver piece of light, and you can see the many more details.
The visible light spectrum, essentially, we're taking a very tiny slice of that?
Yes.
Okay, that's
like
how that works.
less than percent of this visible spectrum. You take it,
Wow.
and you can basically look at the solar chromosphere, not a photosphere, but the chromosphere.
Wow. Okay, that's how they work. Because I'd never have had one. The one thing nice about these dedicated solar telescopes is they are smaller, so physically moving them, it's easier for someone to do. Because a lot of people that I see that have telescopes, as they have them over the years, they may say, I don't feel like moving this, or I can't move them because I physically can't lift it or wheel it out anymore. So a smaller telescope is always something to think about, or a smart telescope. Again, if you have that, if you have the inability to physically move something that's 40, 50 pounds, because they're cumbersome as well. Those mounts are big, the scope is big, and you can't drop them, because then you're in a bigger
don't wanna drop
problem. Then, I mean, and everyone knows that. So that's always one thing to think about too. Old telescopes and new telescopes. What have you seen that's changed with the ages of telescopes over time? And can you use an old telescope? Are they still useful?
So you can look at a telescope as at an investment, in some cases. So telescope, it's not like a car. Like it's kind of like a car. If you drive it, it degrades, the mileage increases, and eventually dies. With a telescope, it's kind of the same idea, but they last long as you take a good care of it. So for example,
an old image like this, or an old telescope rather, can take an image like this.
Yes. So for example, this image was taken not using a telescope, but using a lens that you can pretty much describe it as a telescope.
Yep.
Right? Since we're pointing at the night sky. And the lens that I used to take this image was produced in 1983.
Okay.
So it's been a long time
Yep.
since this lens was manufactured.
It has some years on it.
However, you can still take a good image of it. Of course, it's not just because of the lens, because of the modern sensor that was used on the camera, the special narrowband filters as well. But the good thing about this image actually is you guys, whoever you, like viewers, you saw the image of the M16 nebula.
Mm-hmm.
And on the top of this image, you can see exactly the same M16 nebula. It's just I used different lens that has a smaller magnification. And yep, that's pretty much how it looks like if you take a more like
Let's see if I
wider
can zoom it
field
in
of
for
view.
you here too. I just had to switch my
Yeah.
source. So the top image right here is M16.
Is M16, and of course that you can see that it has much less amount of details just because the lens has 200 millimeters of focal length, and the aperture of the lens is 50 millimeters, while the aperture of the telescope that I used to get this image in better details is 122 millimeters, so
Mhm.
2.5 times bigger. And the focal length of the previous image was 683 millimeters, which is like 3.5 times closer and deeper. And the integration time is also different. The previous image was 27 hours of integration time. This image, just 4 hours of integration time.
Okay, a lot shorter.
Lot shorter. And that's actually the interesting part is that we already mentioned earlier, the better quality picture of deep sky object you want to get, then you want to collect as much light as you can. So as you can see here, 4 hours of integration time still shows you pretty good amount of details.
Pillars of creation right here.
Pillars of creation right here in the middle. Yeah.
Okay. Yeah, look at the detail. Yep, you can see it.
You can see it, but without like fine details.
It's a
the
little
sides-
fuzzy.
It's fuzzy, yeah.
Yeah.
But still, you can get nice images. The good thing, by the way, between this image and the previous one, and basically for people that want to consider getting a telescope, doesn't matter if it's astrophotography or visual, the smaller telescope you have, the easier it's to use. If you have a bigger telescope, there are more things that you need to consider to take care when you're targeting the telescope towards the area, when you're fixing the telescope at one target. So yeah, for the beginners, it's definitely better to use smaller telescopes. And if you happen to find out yourself, hey, I like astronomy, or hey, I like astrophotography, I want to do more, and I want to go for better quality, better images, then naturally you get better telescopes and better optics. So for example, even with me, like in 2012, I started with 70 millimeters Celestron telescope. Like, by the way, if somebody will ask me, hey, you started with this telescope, now you do these images, which
Yeah.
they're kind of good, but in the meanwhile, what I always want to mention is that I'm not the best astrophotographer. There are many more folks that do even better qualities than I do, and they have much more experience. But the thing is, like, you started with this telescope. Can you recommend this telescope to me? I'm going to say no. Because the thing is, when I started astronomy, is that in 2012, we didn't have that much information about it. We had forums like Cloudy Nights, or we had some like smaller forums or
Yep.
astronomy clubs, but there wasn't such like a lot of information, or even the YouTube wasn't popular back in the time, right? And I didn't have much knowledge back in the time because whoever people I ask, they know exactly the same as me, same amount of information, right? Especially those are beginners.
You have to learn as you go with this.
Yes.
Because
so for me, it was a tough way. I was
Yeah.
learning through making mistakes,
Yeah.
right? But now we have lots of YouTube channels. We have
Yes.
lots of astronomy clubs. We have lots of information online. We have even this podcast that people might find useful, and
Yep.
whatever they listen to what we say, maybe it's going to help somebody get into astronomy, right?
Hopefully they're learning something.
Yeah.
Hopefully you're learning something.
So
I
there's
actually learned something just now.
so a lot of information around it, and you actually want to talk about telescopes that you do not want to buy.
Yes. Let's do it.
So
I'm pulling something up here, but yeah, go ahead.
telescopes that you do not want to buy is like you just got an idea of getting a telescope. You're going into Target. In a Target, they have a section with the kits with the telescopes, right? For example, his telescope, $50, nice price. You can get 500 magnification, don't buy it. So usually the telescope, that's actually one of the things that one of the friends told me. Some telescopes that you can find in the store that is not astronomy related is basically either made for kids that you're not gonna expect much. You don't mind to spend like $50 to make a kid happy, or there are some cheap telescopes. They have really good specs on the paper, but they're really cheap. Why? Because sometimes people like to use telescope not to use it for the telescope purpose, but more like for a piece of the interior in the house. So the thing is, there are some telescopes that, for example, if you're looking at the reflector telescope, usually reflector telescope that would have a pretty, like, it's gonna have a good length, right?
Yeah, a good
but some of the
3
telescopes,
feet long.
yeah. But some telescopes, they like couple feet long,
Yep.
but the focal length stated here is 1,000 millimeter, for example.
Okay.
Usually the focal length represents how the length of the telescope, right? And for example, if we're gonna take aside a bit, look at the Schmidt-Cassegrain telescope, they're really short, but they have 2,000 millimeters of focal length.
Yeah, they're
Why?
compact.
Because they compact, but the light goes back and forth there.
Yep. So
right?
basically, it's like having a longer telescope, but they designed it. He designed it to be squished.
But they designed, yeah. But there are reflector telescopes. Reflector, that the one that has mirror on the end. And when you point it to somewhere, then the mirror reflects the light. The light goes to the secondary mirror that is like 45 degrees angled.
Mm-hmm.
And then it goes to the eyepiece, right? But there are some short telescopes, but they have 1,000 millimeter focal length. Why? Because it's either right after the secondary mirror, there is a corrector lens. It's like a barrel lens, but it's bad quality lens. And with these telescopes, you usually won't be able to get good, like sharp images. You're gonna get image, but it's gonna be blurry. And there are some telescopes you can, I'm not gonna mention them,
Right.
and the models, but you can just Google them. You can just see them. It's short, but it has 1,000 millimeter focal length. Usually you don't want to buy them.
One thing I would recommend to do, because it can be overwhelming still, because I can still see someone thinking, I still don't know which telescope I should buy right now. So I think the best way to do it, if you live in the Hampton Roads area, is come to one of the events for the Back Bay amateur astronomers, because this is when we're observing the daytime and we're looking at the sun, but there's also several night events too, where all the members will say, hey, come and take a look through the eyepiece, and they'll let you look through whatever object that we're focused on for the night. And you can see this is this type of telescope, this is that type of telescope. You can see what you want, how big it is. You can ask them how heavy it is. You won't be able to pick it up because we're observing at the time, but you can learn a lot going to one of these events.
That's right. And
this is the best way to do it.
That's the best way to do it. And as you can see on this time lapse, they have a Dobsonian, they have some equatorial telescopes, and that's the best way you can do. Since those events, I mean, they have events just for the club members, but they also have open events.
Yes, they do.
You're going, and they usually point like 4 or 5 different, depends on how many telescopes they can get from the club members. They point telescope to the same area, and you're like, okay, the M16 looks like that through this telescope, looks like it through this telescope. This telescope costs this much, and it's that big. Oh, it's that big, probably it's too heavy for me. I'm not going to be able to carry it like in 5 years. Because usually that's, by the way, the thing, when you get a telescope, if it's your first telescope, you'll probably, if you enjoy it and if you find yourself liking it, you'll probably switch to a bigger one within the period of 3-6 months, a year.
Mm-hmm.
But once you have a telescope that is pricier, but you know that this is going to be for the next few years, then it's something else you want to consider. That's, by the way, what I see on Facebook marketplaces or on cloudy nights. There are lots of people they sell used telescopes, heavy telescopes, and the reason, like sometimes people post like, hey, I want to upgrade to a bigger telescope, that's why I'm selling this one.
Yeah.
What you also can see is that this telescope is just too huge for me.
It's too big.
It's too big to carry, and I just want to get rid of it, and I want to switch to a smart telescope.
Yep.
That I still going to enjoy the night sky, maybe through the smartphone, but still be able to enjoy. And the heavier telescope, somebody can find a use of it.
Yes, it's a great way to get equipment, is a used way, because there's people selling stuff all the time locally and regionally where you can find a nice mount if you want to upgrade that, maybe a finder telescope that attaches to the main one if you want to do that for imaging. There's so many different things that people buy and then that they're reselling for a good price.
And with the clubs, the good thing as well is we're going to look at one of my images, the Elephant Trunk Nebula. So that was taken with a MIT telescope, Schmidt-Cassegrain telescope.
Let's pull that one up.
The good thing about this one, so the telescope itself was produced in late 90s, and this telescope was actually donated to me from the club, from the Back Bay Amateur Astronomers Club, like maybe 4 or 5 years ago.
Okay.
So some people, they sell telescope. The story of this telescope behind it, there was the amateur astronomer.
Yeah.
And he just decided to donate the telescope to the club so that the club will donate it to someone that either knows what to do or like pretty much knows what to do with it.
Or wants to learn more.
Wants to learn more,
Because
yeah.
that's
and
what
was
Telescope 10 is a telescope from the club donated to me. So that's what I've been showing on the air, mostly for planetary imaging, deep sky. I've been struggling with that. It's difficult for me
tough.
to do.
Sweet Cassegrains, they're tough telescopes.
And I'm also doing it at the same time that I'm working. So it's really hard to like, okay, let me spend the next 30 minutes getting the telescope ready. And then, oops, I just missed doing my weather. Like, that doesn't work.
Yeah.
That doesn't work because if I say, I tell my boss, sorry, I can't do weather in 5 minutes because I want to work on the telescope. They'll be like, okay, turn the telescope off, get back to your job. So I'm trying to do both. So I really just focus on planetary because it's the most simple. And I found ways over time to make it easier because like on cloudy nights, a web forum where you can talk to people online, or the Back Bay Amateur Astronomer Club where you can go to the club meetings and ask people. Everyone that I've asked the question saying, I want to stream the view of the telescope over the internet and control it remotely, not really anyone does that. Most people walk down to their telescope and adjust it right there. They don't do it remotely. So I had to figure out that bridge. And then I had to figure out the other bridge of streaming it. And then also the other thing of, if the telescope is a little bit off, if the alignment wasn't correct, or it's just a hinge off, where do I find Jupiter? Because I'm just looking around and I'm seeing all these stars and I'm trying to look at star charts and I'm trying to figure out where I am on Stellarium. And then I'm like, I can't figure it out tonight. Or it's like, oh, no, it's right there. So there's a lot of things that I gave myself as a challenge, but overcome them and figured it out. And now it's pretty simple. I can go out there day of, get the telescope all set up. When nightfall hits, get it aligned, and then it's ready to go.
It's good to go, yeah.
It's ready to go, but it still is a process that takes time. And for me, I require 2 nights of clear skies to do it because it's a lot of setup just for one night, except if there's a celestial event that's worth watching.
Of course.
Like a moon is going to occult a planet, something like that. That's when you got
The one we had with the Mars.
Yeah,
That was a
remember
good
that?
one.
That was
Yeah.
a couple, like less than a year ago now?
Yeah,
That was fun.
In March or February. Or March. It was. I remember it was a winter because I remember it was snow.
There was snow.
There was snow, but the view was gorgeous.
It was great, and it
like
was
you can see this huge moon, and
Mars was behind it.
like the moon, and the Mars is like that small, and that goes right behind the moon.
Yep.
And I was looking at it using both the telescopes, the 10-inch Schmidt, the SET, the one that I used to take the image of the elephant trunk, and the second one was used, the one that I took the image of the M16 nebula. So I was looking at like a wide field of the moon and a close field, and that was just like gorgeous. And that's something that that you can enjoy, like from the city actually.
Yes.
There are some events that the Mars is covered by the moon.
Yeah, blocked by the moon essentially. And it was really fun because the calculations are all done, so you can predict the time that it's going to happen and where on the moon to look.
And the way it's going to reappear as well.
Yeah, so that's what I did. I zoomed in the telescope and we had it live on TV at the time when Mars would reappear. And it was a little bit off on the timing because I forgot to calculate one thing. So I stream the video feed from the computer to the internet, and then I take that feed and show it on the air. There's a delay in that process.
Yeah.
So there's a 30-second delay that I didn't calculate in my head, and I'm thinking, this is supposed to happen right now, and it's not. What's going on? It was an internet streaming delay, but it happened right on cue, and then there's Mars appearing again. It's really fun. So it's things like that. It's things that have happened before and will happen again, but they're very exciting to see in real time.
Yeah.
They're very exciting to see. Like an eclipse is fun to see in real time. These are also just as exciting as well.
That's right.
An image that we've been teasing that we haven't shown yet is this one. Which image is this? This is the last one that we have.
So this one, it's a planetary nebula, and the target itself is called Abel 31. So yeah, by the way, you can like hear us saying M16, M17, Abel 31. So all this means like whenever we call the first phrase like a Messier, that's the name of the catalog.
Yes.
And the number is the number of the object in this catalog. So there is a catalog called Abel, which is basically a catalog of planetary nebulae. And this nebula is called Abel 31. It also has different names with lots of numbers in it, right?
Right.
But the thing is, the feature we're looking at, first of all, it's really huge in angular size. I'm not sure if it's almost the same as the size of the moon, but maybe slightly smaller, right? But this
Okay.
nebula is really faint, and for this image, I gathered 54 hours of total integration time using two main filters, hydrogen alpha and oxygen 3 filter, and basically whatever red parts of the image you see, it's hydrogen of the nebula, and the bluish part is oxygen. And yeah, the nebula itself, as I said, is really faint. And for example, if you take a look through a broadband, by broadband I mean like a regular color camera, and if you take an exposure, you might not be able to see this nebula on a single exposure just in broadband, just because how faint it is, and what you see is just lots of noise. But if you use narrowband filters, it's the kind of same idea as when imaging the sun. If you look at the sun in white light, then you're gonna see just like a spots. But if you take a tiny sliver of the light, then you're gonna see more. Same idea is here. When you take an image of this area of the night sky with a broadband, you might see pretty much nothing except the stars. But if you take a hydrogen alpha filter, then it blocks all the light pollution that you have. Like, although I was imaging under bottle for skies in Venusberg, there's still some light pollution. So you kind of want to cut it off as well. And the filters, like the hydrogen alpha and oxygen filters, they do that. Also, there is some signal from different wavelengths that you want to cut off in order to concentrate your telescope view just on specific areas. And this image, like, I decided to pick the target just because, I mean, while there are a lot of images of this target, there are not a lot of images with this amount of exposure time.
Okay.
So usually people, like, you know, the social media Instagram. So there is a social media called Astrobeam, which basically you can call it as an Instagram for astrophotographers, where you can post your image at a high resolution without losing the quality of the image, right? And there are some images with like 15, 20 hours of integration time, which is still nice images, but with this image with 54 hours of integration time, the nebula itself appears really bright, and what you can see if you pull up the wider field of view of this image, you also will be able to see some reddish thing on the background. And just imagine if this nebula is really bright and the background is really dim, and if you take just a single exposure, whatever you see on the background, the hydrogen areas, you wouldn't be able to spot them just because how dim they are. And,
Got it.
Yeah,
54 hours.
54 hours.
So 2,000 light years away, roughly. This is the distance from Earth. So we're looking at this object 2,000 years ago.
Yes.
Because the light took 2,000 years to get here. This is what it looked like 2,000 years ago, which is fascinating. That's a whole nother topic.
That's a whole other topic, and that's a good topic.
Good topic, but this is very cool. This is a great image. So we're going to take a quick break. We're going to talk about how to find objects or what to look for in the night sky. You brought some books, so we're going to be right back after this. Welcome back to Beyond the Forecast. Here with George Konkov, astrophotographer. Tell me, how do you find what you're wanting to look for in the night sky?
So there are thousands of objects that we can either observe visually or image, right?
Yeah.
And if you're a beginner, you can really basically get lost in all these things, right? And beginners, they usually start with Messier catalog. Messier catalog, there are 110 different objects that are really bright and you can observe with a telescope. So basically pretty much 95% of them available from the northern hemisphere. And but let's say you really want to be able to also understand whether you can see this object at this time of the year. So for example, it's July, and if you want to take a picture over the Orion Nebula, you won't be able to just because it's located on the opposite side of the night sky where the sun is pretty much right now.
Correct.
Right? So here is, for me, as a beginner, there was a nice book. I'm just going to show it to you.
Yeah, hold it up.
Like so. It's called The Best 100 Astrophotography Targets. And the good thing about this book is that it's divided by the period of time where you can observe this object. So I just opened like August 11. You can look at the Swan Nebula, M17. Although you can look at it now, but in August it's kind of the best time to look at it. So based on the time of the year, you can use this book. And this book is also really good just because some of the objects, they're big in size, some of them small in size. And this book concentrates on the objects that you can observe with a beginner, although it's dedicated to astrophotography, you also can use this book for visual astronomy, as you don't have to have a really good and high magnification telescope or high power telescope in order to see these objects. So that's something that you can start with. Or there are lots of YouTube videos where basically every month some YouTube channels post like top 10 targets to watch in July, top 10
Yes.
targets to watch in August,
Yes.
right? And you
Because
can-
the distant objects aren't moving, aren't
Yeah.
changing the schedule of the year, because the Earth's orbit is on a schedule. We know that, so we're always going to have those items in the same part of the sky, same time of the year.
Yeah.
Planets, they don't work like that because they're closer by and they're always moving in relation to us. So things are always shifting. So 10 years from now, for example, even like 5 years ago, Saturn and Jupiter
They
were
were
right next to each
together.
other.
Yeah.
And then now, what is it, 30 years it takes for that to happen again? So in 15 years, they're going to be on opposite ends of the night sky, essentially. So things will keep moving there. But one thing to watch for. Anything else that you wanted to mention today, George, before we end our episode? Where can people find you to see some of your videos? Because I know you put out some videos too on instruction.
I also have a YouTube channel. It's called Astro Creation. So it's one word, but it's Astro and Creation, where you can just find me on YouTube. What I mostly do, like my specialty is deep sky astrophotography, but occasionally I do planetary imaging. I do nightscape photography, which, by the way, one of my recent videos will be about taking images of the Milky Way with just a regular DSLR camera. So somebody can also find that interesting. And yeah, also one of my the ideas of the video I get is from the followers, from the questions, and also by just thanks to YouTube that I cooperate with different telescope manufacturers that send me equipment to review, and if it's like bad, I'm not gonna even agree to do something, because right. Or yeah, if I see that the telescope or something is good and I can share something beneficial with people, right? Or for example, the Meet telescope that was donated to the club, it's a really old telescope, and it took me a few years to finally get it up and running for deep sky photography. So I put some videos, and actually I received feedbacks from people that's like, hey, I couldn't figure out this part. Thanks to a video, I did it. Videos don't get a lot of views, but that's not the main idea why I do it. The main idea I do is just to share my knowledge with people. And the same, like when I watch somebody's YouTube video, so I get help and somebody get help from me. That's kind of how it works.
That's how the community works.
Yeah.
It's great. Well, thank you, George, for coming on the episode today.
Yeah,
this
thank
is
you
good
for having me.
information. This is great. A lot of stuff to kind of go through. Probably going to have to watch it a second time if you missed something.
Yeah.
But if you have any questions, feel free to send them to me. I'll send them to George. We can get those questions answered about telescope specifics or cameras. We didn't even get into that, because that's a whole nother topic. But we're out of time for now. Thanks again. We're going to leave you with this image here, again, of a M16. This is one of my favorite images that you sent me in this suite here. This is a great one. So we'll be back with another episode coming up soon.